Hello and welcome back to Differential Equations section 2.2, General Solutions of Linear Equations. Great. So last time we talked about the second order linear differential equations. Chapter 1 was devoted to the first order differential equations per syllabus. And we are dealing now with general solution to any linear. So we are not only having the fifth order or the second. We can have the third, fourth, fifth, any order, but it is required of the differential equation to be linear. Now remember what linear means. You are not allowed to multiply, divide y's of any kind. So y prime times y double prime, not allowed. You're not allowed to square any of them or do anything that would introduce non-linearity. So technically what's happening for the linear equation, just have the string where you have y, y prime, y double prime, y triple prime, and so on. And you can actually observe them as polynomials, like polynomial-like. So to write the equation, you are going to have, let's say, some function p0 of x multiplied into y to the nth derivative. So when you put those parentheses like that, that denotes you will put y prime, y double prime, y triple prime with three little primes. And then when you go to the fourth derivative, the notation for the fourth derivative switches to the parenthesis notation. So don't get confused. Before this, you have the tick marks, right? And then after this, you are getting the parenthesis notation. So this is the fifth derivative. So when I write this, this means the nth derivative. Could be any of these derivatives that I discussed. So plus p1 of x and then y, and this is the first derivative, right? Less, so minus 1, plus p2 of x, y to the derivative, right? So take that, plus dot, 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 and eventually it becomes p to the pn of x, y equal to 0. Now, we don't like to have the function in front of the first one, so we are going to divide by this p0 x everywhere. Yeah. And that is going to define the lowercase p, which we are going to use. So now the equation becomes y to the n plus p1 of x, y, n minus 1. So this is lowercase p's now, plus p2 of x, y, n minus 2, plus dot, 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 plus pn of x, y equal to 0. Now, solution for this. So this would be our general form of the equation. And then the solution, again, using superposition, would be the good old y of t or x, whatever your input independent variable is, c1 y1 of t plus c2 y2 of t plus c3 y3 of t plus dot, 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 all the way to cn yn of t. And that will be the solution. So as you know, the polynomials would have the number of roots match the exponent. Some of those roots might be complex, some might be real, and repeated real, right? So you have three cases. This exhibits the same deal, right? You will have the number of solutions in terms of y1, y2, and so on will match the amount of derivatives that you had earlier. So the order. Again, existence, uniqueness, all of that stuff, right? So you have the existence of the solution and you have uniqueness. That's the only solution that you have, especially if you get it as the superposition. All right, great. So verify that y1 of x equal x squared, no coughing, and y2 of x equal x cubed are solutions to differential equation x squared y double prime minus 4xy prime plus 6y equal to 0. All right, so this, you are verifying solutions. So what does that mean? What do you have to do? Well, what do you have to do first? Yes, so you have to combine the solutions into a single y using superposition with the two constants. Then you take the derivative and the second derivative and plug everything in. Yeah, so it's going to take some work.
So you would say step one is combine the two y's?
Yes. New Instagram thing on voting. I'm going on voting all day long. Everyone's putting polls on. Cat or a dog? It's important, of course. Dog. Click. What happened? Is there a problem? Good. Excellent. All right, so that's plenty of time for you to solve this. You have the y equals c1 x squared plus c2 x cubed. Y prime is going to be 2c1x plus 3c2x squared, and y double prime is 2c1 plus 6c2x. And now we just plug all of these into the equation above. So we have x squared that multiplies 2c1 plus 6c2x minus 4x that multiplies 2c1x plus 3c2x squared plus 6 that multiplies the c1x squared plus c2x cubed. And then when you'll get 0. So when you FOIL everything and add all like terms, they should all cancel and you should get your zeros all over the place.
Sounds like this stuff bores you.
The labor, it's just the labor over here. We're going to get in some really cool stuff very soon. In chapter 3, power series. Chapter 4, Laplace transform. Right? We are going to extend the notion of independence now from 2 solutions to 3, 4, or whatever, or how many we have. We're also going to use the Wronskian for that, right, with W and K and everything else. And the matrix now is going to have 3 by 3, 4 by 4, 5 by 5, depending on the amount of solution that we have, which corresponds to the order of the differential equation. So first order equation has only one solution. Clearly, it's only one solution, so we don't talk about independence because it has nothing to be independent of. It's just one solution. But then with 2 solutions, they need to be independent, and then 3 again and 4. So now the Wronskian for this is going to have the function and all of the derivatives listed below. And we need them to be linearly independent. So we use Wronskian to check linear independence, and we have the matrix solution 1, solution 2, solution 3, dot, 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 to solution n. And then going below, we have f1 prime, f2 prime, f3 prime, fn prime, f1 double prime, f2 double prime, f3 double prime, dot, 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 f3 double prime. No, that's fn. Yeah. fn, no coughing. And the last one, right, so after this, it's going to be some, because this is infinite matrix in all ways, f1 to the n minus 1, and then f2 n minus 1, f3 n minus 1, fn n minus 1. Depends if you request it. Are you requesting it?
That would take forever.
It's been a while since I've done it. So.
Dude, that will be a quiz on its own.
You know that truck that you have?
Yeah.
And the looks you just got from others? See? The way we deal with linear independence is you populate the matrix. If you have the third order, you will have 3 by 3. And you have to deal with that the same way you dealt with in Calc 3 for cross product, where you break a 3 by 3 into 3 2 by 2s. and then you solve each 2 by 2. If you have 4 by 4, you will create 4 3 by 3s, and then each 3 by 3 will have 3 2 by 2s. So you're going to have how many 2 by 2s? Yeah.
Just say it.
It's
Right.
just going to be a lot of work.
Exactly.
Or you can
So if you start with, you have to start with 4, right? That's going to give you 4, and then each one of these 4 is now a 3, and each one of the 3 will have a 3 to get the 2s, and then the 2. So how many do you have? Yeah, it's combinatorics, so figure it out. The correct answer is a lot, yes. There I say a simple homework problem to check the Bronskin with solutions. Are they independent? They don't have it. I have one example here. Yeah. So we need this to be different than 0, right? For independence. Otherwise, you're doomed. Well, there are ways to fix it, but you can do another example, but 2.2 is done. It just talks about the general case, where whatever we learned in 2.1 is now generalized to any higher order. But let's see what they like. Use Bronskin to prove the given functions are linearly independent, indicated interval. Great. How about number, what do you want, 8 or 10 or 12? No, 12. Taking the best. 8 is sufficiently nice. Because the other ones you can just grind. So y1 is e to the x, y2 is e to the 2x, and y3 is e to the 3x. Very creative, very creative. Bravo. Okay. Come on in, we have differential equations. So we just have one student join the class, which is awesome.
Shall we give him his thing back? From what we found his thing on the desk back there?
Oh, I confiscated it. I forgot it. So, hi. Welcome. I'm going to restart the whole lecture now. You just made a meme, right? Oh. Now, how much do I have to pay to see it?
What?
How much do I have to pay to see it? Is it evil? It is. Oh. Keep it under the table. Come on, let's go. The Bronskin for this.
You do it that way, right? Where you take the two columns, bring over here and crisscross.
Yes, if you know those tricks. Yep. It depends whether you had linear algebra or not.
You what?
Depends. 8th grade.
8th grade? Just learned that over the summer.
Well, we all go to 8th grade different times. So. So are these linearly dependent or independent? Independent, good. Why? Why are they independent? So if you're doing it the Calc 3 way, you pick these up, right? So it's e to the x, and then you deal with this. So I have 18 e to the 5x minus 12 e to the 5x, and then minus e to the 2x. It's 9x 9 e to the 4x minus 3 e to the 4x, and then finally plus e to the 3x, and 4 e 3x minus 2 e 3x. So now this is 6 e to the 6x minus, that's 6 e to the 6x, and then plus, that's 2 e to the 6x. So I get 2 e to the 6x. That's when I do. Is this what you guys have? Okay. Some of you look concerned.
You just added right? So you just did e to x, and then you took that one, and then added that to the e to the 2x. And then,
Yeah, before you started that discussion, what did you circle, the first row and then the box
Yeah.
of 2, 3, 4, 9?
Well, yeah, when you use e to the x,
Right.
then you do the symbol there, right? The determinant.
Yeah, do the determinant.
Because whenever you circle one, it kills that row and constant and column. So you're left with the rest, right? And you do the determinant of what you see. For the second one, you have to put the negative sign. That's usually where mistake is.
Yeah.
So now when you're doing the second one, you cross out these, so you have these ones to do the thing.
Oh,
Minus, yes. I minus j plus k, yep.
For 3 by 3, you can also do this basket weaving method.
Yes, basket weaving method, yep. That's what you did. So, yeah. It's calculation. It's not. And you didn't get the problem wrong because you got independence, so yay.
No, I got not. Both my, probably supposed to add them and multiply each group and get across.
Multiply the way I know. All right. So we're going to restart the stream and start 2.3 after the short commercial break.